Hi there, my name is Rebecca Weaver, and we're going to be looking at section 5.4 today, further exponential models. To begin with, we're going to be discussing terminal velocity. Now, terminal velocity happens when we have free fall time for, say, something like a skydiver. And that function, the velocity, is m times 1 minus e to the minus kt. So that capital M is our terminal velocity. Now this is a differential equation, and to find the solution to a differential equation, the unique solution of the differential equation in the initial condition, we have that y prime of t, that's our vertical distance, equals k times m, which is our terminal velocity, minus that vertical distance. And y of 0 equals 0 means I started from just kind of stepping out of the plane, if you will. And that y of t equals m times the quantity 1 minus e to the negative kt. Similarly, we have a learning curve that deals with study time, and where m is our syllables memorized. It has a very similar function, that f of t equals m times 1 minus e to the negative kt. Learning curve also has a similar function, f of t equals m, which is the number of syllables memorized, times the quantity 1 minus e to the negative kt. Another example using that utilizes this particular function is y equals capital P times 1 minus e to the negative kt. This is population growth. This is population of people who have heard news by mass media. So looking at the spread of news, let's do an example of this. A news item is spread by word of mouth to a potential audience of 10,000 people after t days. And there's our function, f of t equals 10,000 divided by the quantity 1 plus 50 e to the minus 0.4 t. People will have heard the news. The graph of this function will show on the next slide. How many people will have heard the news after 7 days? We're going to answer the question at approximately what rate will the news be spreading after 14 days? Approximately when will 7,000 people have heard the news? And approximately when will the news be spreading at a rate of 600 people per day? That's going to be our calculus problem. And then when will the news be spreading at the greatest rate? Another calculus. So the last question that we're going to answer is we're going to use y equals m over the quantity 1 plus b e to the minus mkt and y prime equals ky times m minus y to determine the differential equation satisfied by f of t. Here we have our f of t function, we have our first derivative, and then our second derivative functions. So to determine how many people will have heard the news after 7 days, we're going to find just f of 7. Total algebra problem here, just plugging in a 7 to our general function, and we'll get 2,475. That means after 7 days, we would expect 2,475 people to have heard the news. Now for our B question, we need to determine approximately what rate the news will be spreading after 14 days. So this is a rate question. We'll need to find f prime of 14. We're going to use the derivative of the function since we are seeking that rate of change. Now to find the derivative of that function, we're going to need to use the quotient rule. So here's our given function. Next we'll use the quotient rule, and then we'll simplify it. And then what we need to do is just plug in that 14 to that derivative value. So after 14 days, the news will be spreading at approximately 526.76 people per day. In the C question, we need to determine approximately when 7,000 people will have heard the news. So this is just an algebra question. We're going to replace f of t with 7,000, solve for t. So straight up algebra here, just simplifying and solving for t. End up, we're going to divide, take the natural log of both sides, and then we'll get that t equals 11.89. So 7,000 people will have heard the news after approximately 11.89 days. Now, to determine when the news will be spreading at a rate of 600 people per day, we're going to replace f of t with 600 because that's a rate. So since this will be a long and messy process and it's good algebra, you can do this. We're just going to look on the graph, which we could do that too, especially if we plugged it into our calculator and asked it to find that value. We need to find when f of t is about 600. So when f of t is about 600, it looks like 600, we have it at about 6 and about, around 13 or so, 13 and a half. So just looking at those values and then reiterating, here we have seen on the graph, it's when our value is 600, t is 6, or about 13 and a half or so. And there's our points. So the news will be spreading at the greatest rate when the derivative is the greatest. That is, when is the derivative rate the greatest? That's here at the maximum. We can set that derivative equal to 0 and solve for that, or we can also look at it on our graph and we can say that it's at t equal 10. That's kind of cheating, but that's what we're doing because we can figure it out that way too. Since we know y equals m over 1 plus b e to the minus mkt satisfies the differential equation y prime equals ky times the quantity m minus y, then we can rewrite f of t in the form y equals m all over 1 plus b e to the minus mkt. Now, upon doing this, we will have defined m, k, and b for our function. So we can just use y prime equals ky times the quantity m minus y to create a differential equation satisfied by f of t. So here's our given function. Now let's do this. Since the number 10,000 by itself is in the numerator, it must be that m is our 10,000. And since 50 is the only coefficient of e to the minus 0.4t, it must be that b is 50. So now we can rewrite negative 0.4 in the form m, negative m times k to determine k, because we know that m is 10,000. So that means if negative 0.4 equals negative m times k, then we know that k is going to be 0.00004. Therefore, we can rewrite our function in terms of this m and k and b. So f of t satisfies the differential equation, and just plugging in each of those different functions and values for y and k and m, just plugging those in, there's our y prime function. All right, cool. So intravenous infusion of glucose. We have m, which is our excess glucose, as r over lambda, and y equals r over lambda times the quantity 1 minus e to the negative lambda t. And this is for our continuous infusion of glucose over time. Here's a logistics growth problem. This is used in different population growth. Y equals m over 1 plus b e to the minus mkt. We looked at this one. An epidemic model. It's kind of a strange one to have here in these times, isn't it? Number one, the population is a fixed number p, and each member of the population is susceptible to the disease. Number two, the duration of the disease is long so that no cures occur during the time period of the study. 3, all infected individuals are contagious and circulate freely among the population. Number 4, during each time period, such as 1 day or 1 week, each infected person makes C contacts, and each contact with an uninfected person results in the transmission of the disease. If all of those 4 conditions hold, then f of t equals p over 1 plus b e to the minus ct. So in this, you'll need to use this formula if you're given a problem involving an epidemic model. In each of those cases, whenever you see one of those problems, you'll just go and get that formula and use it and plug in your values. If it talks about rate, be sure and take the derivative. And that's all we have for section 4 out of chapter 5. Thank you and have a wonderful day.